In this session, we're going to look at a derivation of the limit definition of a derivative. And this is something we're going to be using quite a bit, not the derivation, but the actual limit definition of a derivative. So let's just say, for the sake of discussion, that we have some function. So let's just draw some function over here. And let's say that we have some point here. Let's call this, let's do a little line here. Okay, so let's say that this here is, let's just draw a couple lines here. Let's just say that this is some point x on the x-axis, and then if this function is f of x, then this value is f of x. And let's take another point out here. Let's call it this one. And let's go up here. Alright. And let's go over here. Okay, there. Now, this is going to be some different value. Let's call this, if this distance from here to here, let's call this point C. And if this distance here, we'll call that delta x. This point then becomes f of x plus delta x. Now we can talk about the slope of a line along this curve. Let's talk about the slope of the secant line along this curve. So let's take a line. Let's just draw it like this. So here's a secant line connecting these 2 points. Now, if I want to actually look at the slope of this secant line, then what I actually have, we know that slope in general is the change in y over the change in x. Change in implies a difference. So the change in y is going to be this y minus this y. So we're actually going to have f of x plus delta x. Whoops, we forgot a parenthesis over here. Minus this function, f of x. So this gives us the difference of the y's from this y to this y. And the difference of the x's is going to be, this x is x plus delta x, so it's x plus delta. Let's try that again. X plus delta x minus this x. Of course, that simplifies. These x's cancel out, and what we have is f of x plus delta x minus f of x all over delta x. Now this is commonly referred to as a difference quotient, obviously, because you can see it's the difference of the x's over the difference of the y's over the difference of the x's. So this gives us the slope of a secant line along this curve. Well, what we're really driving at with derivative is we're looking for the slope of the tangent line. Well, we can see that if this point C gets closer and closer to x, this line is going to closer and closer approximate the slope of the tangent line at that point. So, in short, when delta x approaches 0, this distance from x to c is going to be approaching 0, and we will have the slope of the tangent line at point x. So that involves, obviously, a limit process. So what I'm going to do then is I'm going to take the limit as delta x approaches 0 of this difference quotient, f of x plus delta x minus f of x all over delta x. And there you have the limit definition of a derivative. We're going to be using this quite often, and there are several tutorials in the process using the limit definition of a derivative. I hope this helped, and I'll see you next time.